Hello, yeah, 9. Apologies, my voice is a bit croaky. Here we go. Here's a starter. Pause the video. You should know these answers. And I'm unpausing in 5, 4, 3, 2, 1. Here we go. You should know that. Look at number 3. Efficiency is not measured in anything specifically. It has no units, but we can express it as a percentage. Number 2, you should know. We can never get more energy out than we put in. And number 5, we should know what a watt is. A watt is a joule per second. Okay, 1 watt or 1 W. There we go, easy. Red ticket, correct it. You should know these things. Okay, so heating and insulation is all about, excuse me, I do have a cold. It's all about how we keep heat in houses. And this is a thermogram, and I'm going to tell you what it actually is. It shows you where heat is being lost from a house. It's like almost like a night vision camera. It measures how hot different parts of the building are. The hotter the part of the building is, it means that there's heat energy. There is heat energy escaping from there. Okay, so why am I interested in that? I want to save money. Excuse me. I want to not spend money on electricity and gas bills to heat my house. I'd rather spend it on ice creams and physics experiments. Okay. Plus, the less energy we use in our houses, the more environmentally friendly that is. We're producing less noxious gases and so on. Okay, so that's the big picture. Now then, over the next few slides, I'm going to be talking. I'm going to talk through very, very, very quickly. But if you've got access to this, you can access the actual PowerPoint, because what you're going to be doing is creating a table of information about the ways we can insulate houses, what they actually do in stopping heat transfer, whether it's conduction, convection, or radiation, and how they actually work. Okay, so the table is there minimized in the right hand of the screen, and it looks like this. So you should have access to the PowerPoint. So I'm just going to really quickly whiz through this, but your mission is that you should know about all these types of insulation. You should know the type of heat transfer it stops, whether it's conduction, convection, or radiation, and also how it actually does it. So I'm going to briefly talk through it, but you'll need to go back over the PowerPoint to have a look at it. Okay. So we know from this diagram here that most heat tends to fly, or rather escape from your roof and your walls, quite a lot through the floor as well. And here's a hint. This is why we have carpet. Carpet insulates your floor, so it stops heat being lost that way. Okay. Sorry, let's move on. So have a read of this. Let's move that out of the way. Double glazing. It stops heat loss by conduction. If you only have a single pane of glass, one layer of glass, the heat from inside the room warms at the glass on the one side, and the heat travels through the glass and then it can escape into the outside. If we have two layers of glass with a layer of air in between, that air actually acts as an insulator and stops heat conduction. Okay. If we go one better and actually suck all the air out between the two pieces of glass, we create something called a vacuum, and that's an even better way of stopping heat conduction. Okay, so this is double glazing, stops heat by conduction. Moving on. Oops. Now, walls, we usually have two layers of walls in your house. Let's imagine that this where my mouse is, that's the outside layer, and this is the inside layer of bricks, and this is, say, your living room over here. So heat can conduct through the walls, and then it can convect in the air gap. There's a gap between these two layers, and then it can be lost that way, and it can transmit then through here, and so on. So what this method does, and this is called cavity insulation, it stops heat loss by convection, and it also reduces it by conduction, because the foam insulation is full of little tiny air bubbles, which are really good at insulating. Okay. Next one, radiation. Okay. Warm air rises to the top of your house, okay, and then rises into your loft space, where it then heats up the roof, and then it's radiated to the outside. Okay. So what we can actually do is we can put inside your, okay, that's an interesting message. What we can actually put in the top of your, in your attic there, in your loft space, is loft insulation, and that stops the heat basically going through into the loft. Okay? So it basically stops it through conduction, and loft insulation is that's what it does. And the loft insulation has got lots and lots of air trapped in it, little air bubbles, which make it a good insulator. Radiation is all about heat that is radiated, like infrared heat. And one thing that we could do if we wanted to, we could put silver foil behind our radiators, and that would reflect the heat back into the room. You may notice in new build houses where they put in the insulation for the walls, it's got a shiny surface on both sides, and that reflects heat back into the house and prevents heat being lost that way. But obviously, things like draft excluders, that stops heat being convected away on air currents. Excuse me, sorry. So, the curtains do the same as well. What a curtain will do, it stops drafts, it stops air being carrying the heat away. It also stops the radiation. It stops heat going straight through the glass window and outside. Okay. Now then, so you go over the PowerPoint yourself. If you're doing this in class, this lesson, these notes are all printed for you. Okay. If you're doing this at home, then get the hold of the PowerPoint or pause the video so you can get the effective notes onto your sheet. Now, next task here is basic reading and comprehension. This is attached in your Teams file if you access this through Teams, and it's simply just an overview of what I've been talking about. So reading through, doing those questions, obviously with short, meaningful answers. And I'm going to pause the video now. I've talked too much. And now I'm going to restart it. So there we go. These are our answers. Red pen them. Pause it because I'm moving on. So at this point now, you should be able to answer this question. So pause it and look at the question. Look at the data. And I'm going to unpause now because this would be my advice. I'm going to leave it there now. So I will see you next time. Enjoy.